All right. This next question says that a photon has 6.6 kilojoules per mole of energy. What is the frequency of one such photon? So in this problem, it's giving you the energy in terms of kilojoules per mole. So you have to do two things before you can even start to get going with the formulaic part of solving the problem. The formulas that we use are couched in terms of energy per single mole. And on top of that, it's joules per mole. And so the first thing I want to do then in order to start working on that is to convert kilojoules per mole to joules per mole. And a simple conversion from using the metric prefixes would see us calculate that 6.6 kilojoules per mole is 6.6 times 10 to the third joules per mole. Now that I have that, I can use Avogadro's number and I can convert 6.6 times 10 to the third joules per mole by using the conversion factor. 1 mole of photons is 6.022 times 10 to the 23rd photons. And I get 1.09 times 10 to the negative 12 joules per individual photon. Okay, now that I have that energy in terms of joules per photon, I can turn to the formula. And the formula is E equals h nu. Now I need to algebraically rearrange that to solve for the frequency, and I get nu equals E over h. So I just calculated E and put it in terms of joules per photon. So I'm going to put that right there in the numerator, 1.09 times 10 to the negative 20 joules. Divide it by Planck's constant, 6.6 times 10 to the negative, 6.626 times 10 to the negative 34 joules times seconds. And when I put that into my calculator, I get 1.65 times 10 to the 13 per second, and per second is a hertz. And converting that to the correct number of significant figures, or rounding it to the correct number of significant figures, I get 1.7 times 10 to the 13th hertz. And that's my final answer. All right.